The paradigm activity then. Let's start with question 1. Explain your understanding of the term paradigm, then suggest an appropriate paradigm to be used for each of the following purposes. So first of all, a paradigm is a name for a style of programming. And we use these different styles, remember, to help us produce different outcomes. The first example is building a video game that automatically generates enemies for areas of gameplay. The hint there is the automatic generation, because OOP or object-oriented programming is what you want there. It allows you to create a class, which is a template, which can be reused when generating the enemies. So we can have a template for an enemy, and whenever we need one, we just say, another one of those, please, another one of those, please. And that's instantiation, that's creating the object itself. 2, develop a machine learning algorithm that identifies students in schools from CCTV images. So a bit of a creepy concept there, but what would be good for that? It would be a special purpose language, and that gives us a specific tool for training data sets and developing rule sets. Special purpose languages always give us special tools to enable us to achieve the end result that we want from that specific purpose. 3, teaching primary school children how to develop simple programs using a standard set of programming constructs. A nice technical way of saying basically we want visual programming languages because it allows them to drag and drop things without having to learn the syntax or memorize the commands. Part 4, adding interactivity to a standard HTML website. Well, that would be scripting because JavaScript is what we need to allow that interactivity to happen. The OOP diagram is reasonably straightforward. We need to design an OOP diagram that is for jobs in a school, including teachers, heads of department, and administrative staff. There's a bunch of data on there that you need to make sure you've stored, but let's have a look at what we'd start with. I'd start with my first class as being a job, because everyone needs to have a name, and therefore if everyone needs to have a name as a property, then the methods need to have set and get. And we often call these setters and getters. The properties are the data, and the methods are the setters and getters to change those properties. So let's start with one of the jobs. Let's inherit from job to teacher. So we get name for free, and we also need the subject, and therefore we'll need to include get subject and set subject. And then if we inherit from that for the head of department, who is a teacher, we'll need to know their department, their set department, and get department. Now remember, the head of department will be able to access name and subject and department in their properties, and all of those getters and setters as part of their methods. Let's inherit again for the admin staff, and the important thing here is that's inherited directly from job. We need the name and we need the work hours. We've got name already due to the inheritance, so we'll put the working hours in there and we'll have getters and setters for that within it. And that's that. The standardization activity then, explain why standards are important for improving the development speed of any technologies that rely on those standards. Well, standards mean that everyone working on the development of a technology works from the same specification. And that makes sense, doesn't it? Because if they all work from the same specification, then they will all be able to understand what they're expected to build. Standard libraries can be developed then, so multiple teams are not working on re-implementing the same technologies. And then finally, faster development happens as a result of all that because we're not having to reinvent the wheel. The unambiguous representation activity then basically gives us a definition for how a company wants to store their backup names. We need an exclamation mark symbol followed by 3 letters that represent the server being backed up, and finally at least 1 digit to represent the backup number. So how are we going to define this? Well, let's start with a syntax diagram. I need to define a letter. Now, I've been a bit lazy here and just put an ellipses at the bottom, but there should be 26 letters there, shouldn't there? Digits on the right, I've defined that. It could be any of the single character digits. And my syntax diagram is reasonably straightforward. It starts with the exclamation mark, and then 3 letters and 1 or more digits. Notice the loop there to say 1 or more. I could just put 1 digit in and leave, or I could keep adding to that infinitely. How do we represent that in BNF then? Well, it's a little bit different. We need all the letters represented there, and you'll see how much easier it is to actually represent the letters in BNF than it is in a syntax diagram. Then we need to represent a digit, which again is reasonably straightforward, but it's the number that's the interesting one. The number is recursive. It's either a digit or it's a digit followed by a number. So I can have 1 or any number of numbers here put together. Then in defining the final name, it's reasonably straightforward. It's the exclamation mark, a letter, a letter, a letter, and a number. Now, because we've got those previous definitions, that makes it much easier to understand.